Hi, this is the video for section 6.6 for geometry. I actually am going to have to apologize. I have to do two videos for this. There's a lot of stuff in trapezoids. I'll just make one for that, and then the one for kites will be on a separate video. So, section 6.6, here we go. Trapezoid definition is a quadrilateral, okay, with exactly one pair of parallel sides. And that's different than a parallelogram, because a parallelogram is exactly two pairs of parallel sides for us. Some textbooks define it differently, but that's not our book. The parallel sides are called the bases. So A, B, and DC are parallel; they're the bases. And then the base angles are formed, or then the other two sides, the non-parallel sides, are called the legs. And the base angles are formed by the legs, meaning the bases. So we actually have two pairs of base angles. We have D and C. They're a pair of base angles because they're on the same parallel line. And then we have A and B. Those are other pair of base angles. And if the legs of a figure are congruent, if the legs of the trapezoid are congruent, that means it is an isosceles trapezoid. So those are our first two definitions for this section. Now, as far as our theorems are concerned, in this first part, all of them have to do with actually an isosceles trapezoid. For us, the trapezoid itself has no independent theorems. So there are three theorems for the isosceles trapezoid. Three for this section. The first is if the trapezoid is isosceles, the base angle pairs are congruent. So that's our first one. So G and H are congruent, F and J are congruent. Excuse me. Theorem 622 is that if the base angles are congruent, we know it's an isosceles trapezoid. So it's really the converse of 21. Okay. 22 is. And then 23 is one that we had to be very careful with. It's easy to confuse this one because the diagonals are congruent is what it says for isosceles trapezoid, but that's very similar to a rectangle, so make sure you know which one you're talking about. The isosceles trapezoid has congruent diagonals, not the regular trapezoid, not the plain boring one. Okay. And so does the rectangle, has congruent diagonals. Another definition is the mid-segment of a trapezoid. The mid-segment is the segment that's exactly connects the two midpoints of the legs of a trapezoid. The mid-segment has its own theorem as well, and it is this one. If you have the mid-segment of a trapezoid, meaning you have the midpoint of both legs connected together to make a new segment, it has two parts to it. One, it is parallel with the two bases. So all three of those segments are congruent. So this one right here, this is the mid-segment BE. Okay. Segment BE is the mid-segment. Now that segment is parallel to both AF and CD. It's also the average of AF and CD. Now the book will say it's 1/2 the sum, but that's really what that means by 1/2 the sum. Just average AF and CD, and BF or BE is right in the middle. So all of our problems basically in this section for trapezoids deal with all these properties. So let's look through some examples. The first example to take a look at is, here we have a quadrilateral with four given vertices. We want to verify that the quadrilateral is a trapezoid, and then determine whether or not the figure is an isosceles trapezoid. So I'm going to cheat because I can on the computer. I've got 4 points. A is at the point -2, 5. B is at the point -3, 1. C is at the point 6, 1. And D is at the point 3, 5. Okay. Now you'll need to do this first for any of them. You'll have to graph it to take a look at the points. Like I said, I'm going to cheat because I'm just going to graph it on the computer here instead of graphing it on paper. So point A is going to equal -2, 5. Okay. Point B is going to equal -3, 1. Point C is going to equal 6, 1. And point D is going to equal 3, 5. Okay. So we needed to know where those points are at because now I can sketch it out and I'll connect the segments. And I'll also need to know what the labels are, so I'll turn those on. So here's point A, here's point B, here's point C, and here's point D. I want to look at these not because it's like busy work, but I want to verify whether or not this is isosceles or just a regular trapezoid. Well, the way I'm going to determine if it's a regular trapezoid is by finding, do I have two parallel sides? And the two sides I have are AD and BC. So when I go back to my paper now, I know what I'm looking for is AD parallel to BC? That's what I want to know. So the way I'll verify that is I will find the slopes of AD and BC. If I hadn't graphed it, I wouldn't know what sides I'm looking at, so that's why I have to sketch a graph of it real quick first. So slope of AD, y minus y, 5 minus 5, over x minus x, 3 minus negative 2. I get 0 over 5, because it's minus negative 2, which is really 3 plus 2. And my slope is 0. Now, if this is truly parallel, segment BC will have the same exact slope. So y minus y is 1 minus 1. X minus x is 6 minus negative 3. That ends up being 6 plus 3 on the bottom. We get 0 over 9, 0. So those slopes are the same. And yes, that means then AD and BC are parallel. Now, just being lazy here, because again, this is going to be a really long video. If I don't, kind of take some shortcuts. If you look at the drawing here, if this is isosceles, probably the quickest way of proving it is showing either AB and DE are the same length, which I could do, and show you that they're different. And I'll let the computer do that for me. So AB is 4.12 in length. DC is 5, so they're not the same length. Now I would use the distance formula to do that, so I'd find the distance between A and B and the distance between D and C and show that they're different. Another thing you could do as well, it still requires the distance formula, is you could find the distance between AC and DB and show that those are not congruent, because again, if it is an isosceles trapezoid, the diagonals are congruent. So these are not. It fails that test. Okay. All right, so that's that problem. So let's move on to another one. This is mid-segment. That's what this is. The 16 through 20 here, even they had to do for homework, is proving we have mid-segments that we're finding lengths of or finding legs of other bases. So for, like, let's say number 16, okay, we have. I'm just going to sketch this out loosely by hand. QRSTUV. Okay, so we really can't sketch in our book, but I can kind of loosely sketch here by hand. On, let's say, number 16, they tell us that QR is 12 and UT is 22. The question is, what is VS? Okay. So here's the sketch of what we have. Okay. So QR is 12, UT is 22. The question is, what is VS? Well, the easy way to do this shortcut is, hey, this is the average of 12 and 22 because it's the mid-segment. So it's parallel and half the sum. So VS is 12 plus 22 divided by 2. Okay. So 12 plus 22 is 34. 34 over 2 is VS. VS is 17. Okay, great. Let's see another one of that real quick, if we could sneak it in. Let's see, how about one where we solve for V? We solve for like QR, so like number 18. So number 18, let's use the same drawing. Number 18, you know this time that VS is 9. You know that UT is 12. The question is, what is QR? So I'll call that X. So again, I know this time, just ignore those previous problems. VS is 9. UT is 12. And QR is X. Let me zoom this real quick. Do an auto zoom. Okay, so we know those values. So what we're going to do then is we're just going to set it up. Same thing as before. Vs is the average of QR and 12. So it's x plus 12 over 2. First thing we'll do is double both sides to get rid of that division of 2 here. That gives us 18 equals x plus 12. Subtract 12. X is 6. So in that case then, QR is 6. All right. Okay. Next example, take a look at from the homework. Number 36. So we have another isosceles trapezoid problem. Okay. So they're telling us on 36, the measure of angle ABC is 4x plus 11. And they're telling us that the measure of angle DAB is 2x plus 33. And I'm just drawing this in the background now. So 36. So measure of angle ABC is 4x plus 11. Measure of angle DAB is 2x plus 33. They want to know to find the value of x to make it isosceles. Okay, so looking at this problem then, the only way we're going to make this isosceles is if this guy has either congruent diagonals, which they haven't mentioned anything about diagonals, or congruent base angles, which is what they have mentioned. So we're looking at angle ABC. So here's ABC. It is 4x plus 11. Okay. And then angle DAB, which is the other base angle that corresponds to angle ABC, it is 2x plus 33. So the only way this can be a trapezoid is if these two guys are equal. So 2x plus 33 equals 4x plus 11. So subtract 2 x's from both sides. Subtract 11 from both sides. 22 equals 2x. Divide by 2. X has to be 11. Okay. Now the last example that we're going to take a look at. Oh no, sorry. Yeah. Last example here is one of these on 41, number 42. Okay. So number 42. So again, we're working with the mid segment. Let's see here. Draw out the copy of QRMSTP. QRMSTP. MP is the mid segment. And on 42, we know that TS is 2x. We know that PM is 20. And we know that QR is 6x. And the question is find x to make it the midpoint, or the mid segment. So here's our drawing. The mid segment says that it is this average of those two. So 20 equals 2x plus 6x over 2. At this point, you can do one of two things. You can just flat out double it, which is kind of probably the way to avoid any fractions. But if you'll notice here 2x plus 6x is going to be 8x. So it's even anyway. So you could double both sides, canceling off the 2 here. Or if you add those together and you get an even expression, just divide it by 2. 20 is equal to 4x. Then all I have to do is divide by 4. There, x is 5. So I apologize, this one's kind of long, but there's a lot of stuff with trapezoids in this section. So if you only need help with trapezoids, you're good. Go on to the kites. If you need help with the kites, jump over to the other video.